everybody. This session, hybrid modernization, about combining OpenRewrite precision with LLM intelligence for Spring. So my name is Raquel Pau. I'm technical product manager at .com. I have been a speaker at several conferences, and this is the third time in Spring I/O. If you want to reach me at any moment, please use this email. And for your interest, my background is on developer tools space since 2014. And I'm going to present not only, I would say, my thinking, but as well the thinking of many, many other engineers that are at .com. So how many of you have had this feeling when you are using your coding agent, trying to upgrade a Spring, trying to convert from a legacy technology to a Spring, whatever? Please raise your hands. Wow. It is not an strange. So in this session, what we are going to see is how we can reduce the amount of time the LLM needs to convert your legacy application into the latest and greatest version of a Spring. And hopefully, right, the results are much better than if you leave the LLM alone. The main reason or the origin why you have started probably this activity is because you are looking for standardization across all your apps. Because there are very clear benefits. You want to have efficiency from an engineering perspective because you can share more components that are not only for a single app, but across several team members. And then you want to prevent duplication. And finally, you want to promote that teams can come up with common ways of working. Because if you centralize your tooling, then the way of working naturally becomes the same across the organization. And we all see the ideal world. We all see the dream, right? Standardization basically means, in case that you are using a Spring, that the same Spring Boot version is used across all your projects. And every time there is a new version of a Spring, all projects are being upgraded. And finally, all projects can stay quickly can move quickly to a Spring, no matter what is the original technology. It doesn't matter if it's JAX-RS or if it's a COBOL application or whatever legacy language you are using. But let's be honest, the reality is quite different. You have different versions of Java across all your apps, different versions of Spring Boot, right? And not to mention other frameworks, right? So how we can deal with all these problems? I want to start with some very basic knowledge points. One is the way that we can categorize modernization or coding tools. There are two main categories. One are the deterministic tools, which basically is giving an input, it always produces the same output. Renaming a method is a deterministic problem, right? You know exactly how it's going to look like, your code, after you apply that small refactor. But there are as well non-deterministic problems, like generate my Java documentation from my existing code. There are multiple ways to generate the text and the description, right? And hence, there are many opinions. LLMs usually fit under the non-deterministic approach, right? Because formally speaking, it's just a matter of having multiple options, and then probabilistically, the LLM chooses one of them. So let's start with the first category, the deterministic solutions. OpenRewrite, if you haven't heard about it, is an open source project that basically allows you to program and develop your deterministic code transformations. And it's super powerful because it has type attribution, which means that it's able to resolve all the types of all the expressions that appear in your source code because it has access to the compiler metadata. And after making those changes, is preserving the existing style format, right? And as I said, this is a solution that is a perfect candidate to perform deterministic changes in your code base. And the most important thing that you should remember is that it's not only the part that is deterministic, but also the fact that because of this nature, it's very easy to test your code changes. But this nature, besides has many advantages, have some limitations by nature. It's not that OpenRewrite is not implementing something. It's basically because it's this kind of category of tool, there are some problems that cannot be solved, right? One is that you cannot perform runtime analysis. If you pick OpenRewrite as it is, you cannot fully gather if a particular variable is being used or not, right? We can, and in case of a Spring, right, we are using dependency injection all the time. Dependency injection is something that is resolved when your application bootstrap. And hence, you cannot understand the relationship between all your components and how they are used because it's part of your runtime behavior. And this is a classical example. So internally, Spring Boot is basically creating objects using reflection. Those objects are not visible in the code base of your application. Those instances are not visible. And this reduces the amount of analysis that you can do for a particular reason. Why this is important? Because in some cases, when you are designing deterministic modifications, when you are replacing one method by another method, this second method might extend the number of exceptions that can be thrown, or could use a different modifier. And hence, you need to deal with all the references of those methods to understand if you can propagate those changes as well or not. And it's quite complicated. And besides, you can take advantage of data flow analysis, which, by the way, is available. This is, by definition, for all this kind of data flow analysis tool, a memory-intensive problem. And in practical terms, this means that when you are designing this kind of deterministic changes, you could probably end up with corner cases that are producing compile time errors. Having said that, I want as well to mention that the runtime analysis is something that you can get when you mix OpenRewrite together in the modern platform. But it is not something that you get out of the box. The second limitation, as I was kind of introducing with the Java documentation, is the Java semantics extraction. So what does it mean? That when you are usually, imagine an ensembler, for instance, right? When you are moving from a legacy technology to a modern framework or a modern technology, what is really happening? You are creating higher level constructs that are not in the original technology. And hence, you cannot directly map one by one all the original calls or the original reserved words into the target framework. And if you do, you are going to have the same problems because it's going to be as much verbose as the original language. In order to do that correctly, you need to understand what this full set of statements mean and how they can be simplified using the new advantages that are in the target technology that you are trying to move on. This is an example that we are going to see in action about, for instance, trying to migrate from JAX-RS to Spring Boot. Initially, they are not so much different. But in practical terms, if you really want to take advantage of a Spring Boot, you need to understand what those filters that you have in JAX-RS are doing. Because depending on what they are doing, you need to configure a Spring Boot in a way or another, right? We can see that in token validation, for instance, or if you want to control the catch, header logic, or the throttle logic. You want to limit the number of requests that can be produced, right? And how are you doing exactly this with JAX-RS? Basically, they have the notion of name binding. You create your own annotations, and for those own annotations, you are linking what the filter performs with the URL or the service. And then you are saying, well, I want to execute this filter for these particular URLs. But at the end of the day, those name-binding annotations are in your own internal application annotations. So there are no explicit semantics, right? And if you want to move this JAX-RS filter to Spring Boot, of course, it's a matter of practically changing the base class from where they are extending and adapting a little bit the filter method. However, as you can imagine, the types do not match perfectly. And besides, you can do some of them practically right, some of them cannot. And at the end of the day, if you leave them as they are, you are going to get compiler issues. So yeah, just to conclude, this practical example of authentication requires to use a Spring security. And only in that case is when we need to add the pre-authorized method and get rid of all the, in this case, authenticated annotation that are spread across my filter and my resources. And finally, the third limitation is that besides OpenRewrite can support multiple languages, multi-programming languages, you cannot define cross-language transformations. You cannot migrate, for instance, from JavaScript to Python or from COBOL to Java, right? And we are going to see how we can perform those migrations in a way that produce better results. Because you need to, whatever you are migrating from, need to be compliant with the existing API contracts and as well the APIs that the application is performing outside. So as a simplification or a summary about OpenRewrite, the main benefits is that it's deterministic, and because it's deterministic, it's easy to test. Easy to test, but also cheaper to test. We will see that in reality. But there are some corner cases if you are really making, I would say, complex migrations, or you are not in the same, you are not making changes about the same technology, that is not complete enough, or you need something else, right? One is runtime analysis, code semantics, and cross-language translation. So then AI appeared, right? And this is basically what we have seen so far. At the very beginning, 2017, the first paper of transformers was published, and we have a first emerging model, the OpenAI GPT-3, that was about code generation. Afterwards, we discovered Copilot, GitHub Copilot. That was 2021, the first version of GitHub Copilot, and was basically a tool that gives us the experience of auto-completion. Depending on where we have the cursor, it's trying to make a suggestion. But the thing is that we are even farther now, because in 2022, 2023, we were able to explain code, right? We were able to say, generate me the code for this unit test. And this becomes a general practice among us. And of course, GitHub Copilot adopted all these benefits as well. And now, since 2024, we have agentic coding tools that are going far from those autocompletes, and when we are asking to, for instance, upgrade a Spring, they are trying to perform changes across all the code base. It is not for a single file or modification on a single file. They are going far away and modifying all the files in the repo. Just a brief description of a coding agent. So formally, we can say that this is an autonomous AI system that, given a project, right, when the user starts a conversation, it's important to phrase or remark the term conversation here, because it's giving the limit of what can be talked or integrated as part of the changes. The user provides a message, and the LLM is trying to give an answer based on the model and the available tools and the skills. And it's continuously trying until, for instance, the project compiles, right, or pass the tests. Coding agents are partially solving, somehow, because sometimes it's kind of the feeling, the limitations of OpenRewrite. Besides, they could be super expensive, because until you end up in a situation where your code finally compiles, you might have wasted tons of tokens. And probably is not code that you will be happy to see. And you need to throw away that code and start again. So, but having said that, they are giving the option of translating between different programming languages. You can understand the semantics of the code for those cases where you cannot actually create a deterministic rule, because it's a set of statements that needs to be understood and mapped against something. And it does not perform runtime analysis, but it's using pattern-based reasoning. And I want to highlight something, which is that, as I was saying, OpenRewrite was giving type analysis. It was annotating or resolving all the types of the code base. Coding agents do not have this capability. It might look like, but they don't by default. In the last coding agent versions, in some of them, you can configure the language server protocol to connect to the IDE or the compiler and obtain that information. But this is not something that is provided by default in many of them. So this is why every failure requires a new iteration. So, coming back to the same part, types are not really resolved. They are just estimated based on pattern matching. And hence, when you are, for instance, in your application using libraries or components that are internal libraries that are not open source, they are not widely used, the agent might not know what they are doing. Right? And this is a critical problem, because the agent, the only thing that it's going to do is to produce hallucinations or create its own implementation. And maybe you don't notice, because probably the agent will continue until the end. So you want to really create an experience when you are designing this kind of migrations, where if something is not really known, you need to provide additional context. But we have a limitation as well, which is the context window. Because large projects might exceed the context window. And this is one of the main reasons why the code that is generated by the LLM usually don't meet your expectations. And hence, but you are going to see this as well, you need to divide and conquer this problem in different pieces. And Finally, just to push again about the testing part, how do you test your non-deterministic parts? Of course, there are evals. There is a way to create evals and evaluate if your skills and your agent are using the tools that you have created properly. But nobody talks about the complexity of building and maintaining those evals and how much expensive they are. And especially in the context of code modernization, it requires to have several repos or even request the LLM to generate new repos and execute the same modernization across all of them. And then statistically, if they are matching your success criteria, then your changes on a skill that usually are very common, right, can be applied and merged. So this is why the recommendation is use determinism as much as possible, because it's easy to test, it's saving you tokens, right, and you can maintain those kind of upgrades at scale much more efficiently. So usually there is this question, and we have had this question internally as well, right? Should we use coding agents versus OpenRewrite, or should we combine them? And if we need to combine them, how they look like? What is the best strategy to combine them? We have decided to combine them. And we are going to see what is the best way that we have found at Broadcom. So as you know, OpenRewrite, and if not, I'm going to give a brief description here. The way to run OpenRewrite is through Maven or Gradle. Right? It's just a plugin that you execute, and you provide the amount of recipes, which are the programs that are describing your code changes that need to be executed. So how we can give the LLM, I would say, the option to run that CLI, or any other one that internally might use OpenRewrite. So the coding agents can be extended through MCP, as we have seen in the keynote, right? And there are two types of MCP, remote MCPs and local MCPs. OpenRewrite or any CLI that is for development purposes need that your code is stored locally and should, for instance, have access to your tools to build that project. Because if the compiler is involved in all this process, right, you need to be able to resolve all the dependencies. So this is why, in case that you want to combine both tools, in order to expand the LLM, you can consider only a local MCP server. A remote MCP server shouldn't be an option because of this reason. Otherwise, you need to replicate somehow your local or CI environment somewhere else. And if you are managing multiple repos, this becomes a problem, a maintenance problem in terms of, for instance, security tokens of your internal Maven repos. However, local MCP servers are a really good option in order to reduce the context window, which is the main limitation that coding agents have, because it is the amount of information that they can understand for a conversation. And why? Because you only see the command that has been executed and the result, nothing else. As a second option, you can use skills. And those skills should execute the CLI. The important part of skills is that they are only executed when the LLM decides is the problem that needs to be solved. And hence, all the information associated to the skill directly or indirectly will not be loaded into the context window unless the skill is relevant for the LLM. And finally, the third option is to provide prompts in remote MCP servers. We have tried as well with resources, but we found the limitation of resources that in case that you want the user to execute a command, is not going to execute that command for security reasons. So the only option is to give a prompt that the user can explicitly ask the LLM to execute, and hence those commands are going to be executed. The problem and the main difference between prompts and skills are that prompts need to be fully loaded, the text needs to be fully loaded into the context window, no matter what. So when you are configuring your MCP server, no matter the conversation that you start, that information of the prompt needs to be part of the LLM. And, as you can imagine, if you are trying to migrate, as the example that I was trying to give at the beginning, from COBOL to a Spring Boot, the amount of information that you need to let the LLM know is quite intensive. We all talk about modernization, but it's a very abstract term and usually is used for different types of problems. And every problem should have a different solution, because maybe they require a different user experience. We have categorized modernization in 3 categories. Upgrades, which is about replacing APIs of a given framework for new APIs of the same framework, right? Migrations, which is kind of similar to upgrade, but we are changing the original and the target framework. Okay? This is the example of the JAX-RS to a Spring Boot. Okay? And for instance, we can also consider, if you haven't heard that yet, to move from a Spring retry to a Spring framework, because as part of the Spring Boot release train, sometimes projects are being moved, and classes need to be reorganized. And finally, full rewrites, which means that, well, I cannot reuse anything from the original application. It's a full rewrite, right? The only important thing is to keep the requirements the same. This is the example of from COBOL or even from Scratch, right? Because it's so much different from a Spring that you need a full re-architecture, and then it's a full rewrite. There is almost nothing to keep. And now we are going to see an example with a demo of each of them and how we have approached them. Let's start with upgrading to a Spring Boot 4. In order to upgrade to a Spring Boot, you need to have a plan, basically. And this plan is something that is very personal. When I mean personal, it means that it depends on every project, because every project can use different versions of a Spring Boot, right? And most importantly, when you are upgrading to a Spring Boot, you probably need as well to upgrade third-party open source components that a Spring Boot depends on, or because those are using a Spring Boot. And why not internal libraries? Because we are working towards standardization. And it's very common that organizations have their own internal frameworks on top of frameworks. And hence, you want that your dependencies and your upgrade is not only taking into account a Spring Boot per se, but as well all these other projects. So that's why you need a plan. And to be much more explicit, your internal frameworks might not provide new versions every time there is a new Spring Boot version. There might be hops between them. And you need to produce those hops as well on the consuming applications. But as you can see here, for the Spring retry, there are migrations as well as part of the upgrade, right? So upgrades per se are not only sometimes basically changing APIs in the same framework. You might have as well some kind of migrations. What have been the best practices that we Broadcom, Tanzu Broadcom, recommend for Spring upgrades? First of all, you should use the same OpenRewrite version across all your recipes, no matter if they are for Spring Boot or internal projects. The second one is that you need to create your own or use an engine that calculates this upgrade plan. Otherwise, teams need to manually pick the recipes that need to be executed. And this might be very error-prone and requires to leverage on a knowledge of who is providing those recipes that can be spread across silos. And this upgrade plan needs to be based on basically maybe metadata as a source of truth, right? Otherwise, you cannot verify the correctness of it. And what is the benefit of having an engine on top of OpenRewrite recipes? Basically, that those recipes can be produced or generated or published in a different order than the libraries that are actually available. And then you are making the upgrade recipe agnostic. So after the recipes are available, they are magically applied across all the projects. Also, because, as I was mentioning, if you have your own internal frameworks, there might be hops between different versions of Spring, because every project might have their own release train and its own frequency. And Tanzu platform offers the way to create an upgrade plan with the command CF repo upgrade plan. So it's part of the platform as well. And you are going to see the demo here. So in this example, I'm picking the Spring Pet Cleaning application and a version that is using Spring Boot 3.3. So I'm simply executing this command, and is understanding from my project dependencies what project needs to be upgraded, right, and how they should be upgraded together. As you can see, as part of the Spring Boot upgrade, we are as well upgrading Jackson, which is, in this case, an optional upgrade, by the way, and JUnit. And the resulting application, after applying the upgrade plan, is what we are going to see. If we execute CF repo in this case, apply upgrade plan. This ease of use and CLI-centric is helping you to create those continuous upgrades in your CI/CD pipelines, basically. And the idea here is that you can build your own tool as well, right, in the same way, in order to make your applications recipe agnostic. I have proceeded with apply upgrade plan and squash equals to, because I want to show, in this case, the final execution if I join both steps, step 1 and the step 2 together. But the idea that I need several steps is what is creating a small pull request that can be easily reviewed, right, and can be incrementally integrated. Because at the end, the goal is that the application, after you apply one of these steps, can build successfully. And is a certain amount of changes that anybody of the team can feel comfortable reviewing and merging it. So you are accelerating the upgrade by reducing the scope of every step. In this case, we have executed until the last version. And then when we apply the git diff, in this particular case, as you see, right, some starters need to be introduced, and some dependencies need to be changed. And as well, some classes have been relocated according to those starters. And some important detail, at least this is our recommendation as well, is that upgrades need to be backwards compatible. You don't want to force people to use the latest version, because the latest features, I would say, that can break your runtime behavior. So upgrades are disabling all the best practices that should be a recommendation for new applications only. And this is it. So, and then, yeah, finally, as you can see, all the changes can be evaluated by running the tests, and the application is going to be finally succeeding. OK. Now, let's go to the second biggest problem, right? Move from something different from Spring Boot. this is not just a matter of executing a recipe and that's all, because as you probably know, Jakarta JAX-RS can be used together with Spring already. And hence, if you simply produce a recipe that migrates from JAX-RS to Spring Boot 4, what about those applications that are using Spring Boot 3 still? Right? And Jakarta, they need to switch to Spring Boot 4 and then do the migration. Right? It's a little bit tricky. So what you really want is to migrate to the minimum version or equivalent version of a Spring Boot and then upgrade from there. Because you have all these recipes that are already upgrading from lower versions of a Spring Boot to the latest and greatest. So you can apply all together as a chain, and then dynamically, depending on the version of the Spring that you are using, the migration will succeed targeting the right version. We have seen that multiple times. And as I was explaining as well in the introduction, right? Some changes are easy to do, right? Like container request filter to once per request filter. But some changes are not easy enough because there might be modifier changes, there might be exception changes that can introduce compiler issues. And finally, usually when you are making this kind of modernizations, you are deciding to use higher level constructs, and then you need to understand the semantics of the code. So what's our recommendation on how we decide to approach this problem? Our recommendation is that you create a skill that is about that particular migration that is going to execute a CLI to execute the corresponding recipes. And why not? You need to as well include the upgrade plan as part of the migration. And finally, after those recipes are applied, as I was introducing, there might be compilation issues, and you need some semantic mappings. Those are perfect candidates to resolve using your coding agents. And then this top-level skill can orchestrate all this behavior, recipes and non-deterministic or semantic changes altogether. And then you finally are going to have, when you execute the top-level skill, a better application that just asking your LLM to migrate to a Spring Boot. And you have saved some tokens from the recipe execution as well, right? The, I would say, negative aspect somehow is that then you need to start maintaining these additional skills. Some of them could be easy. I would say resolving compiling issues could be kind of easy to validate. But the semantic follow-up is a matter of understanding several projects and gather feedback. And then it means that you should have an enough number of projects that are representative enough to get good results at the end. And by the way, something that we have learned as well from this experience is that LLMs are as well a very great tool to generate application examples. And this is the second demo. So I'm with Cursor, and in this case, I have generated this application, which is an Spring Pet Clinic application in the same way, but fully written in Jakarta JAX-RS. As you can see, we have all the Jersey and Jakarta dependencies, no dependencies at all yet for Spring. And we are going to start this application. And what is interesting, right, is that we are using name bindings here. However, because there are no, so we are using name bindings here. And you can see the authenticated annotation, which is a name binding, and the throated annotation as well. And this is in the owner's API. Because we have started the application, we can see that is actually working the throated part. Because if we perform multiple, well, this is the authentication part, and if we perform multiple API request to the same endpoint, at the end, we are going to receive an error that says that there are too many attempts. Now, this is the filter, right? It's the container request filter, the name binding here, because it's part of com.example petclinic throttle, right? And the authenticated follows the same approach. And what is curious as well, right, to see is that we have some classes that are called repository, but they are not using yet the Spring convention. There are no repository annotations to load these classes when the application starts. So let's use the skill. So the skill is going to execute the CLI, which internally is resolving the upgrade plan, including the project of Jakarta, because usually the reason why we preferred to have a separate skill rather than integrate that in the general CLI for the upgrade plan is because this is usually an optional step that you want. This is not something that you want to apply continuously in your CI/CD pipelines. It's something that eventually you execute, and it's just an option. So this configuring your repository for Jakarta JAX-RS are running the recipes at this point. And here we are. As you see, there are several compilation issues that have been detected. And indeed, you see the static property that is highlighted in the line 63. This is why the write response method that has been introduced as part of that migration is not working. So now it's proceeding the skill with all the compilation issues. And continuously, I have shorted the video, is continuing with the semantic part, that is translating those name bindings to the corresponding Spring Boot components. So this is why they are completely deleted and replaced properly in the service. It's continuing to complete the configuration. And finally, as well, the repository has been added with the repository annotation, basically, which is as well kind of semantic change. Cool. And then let's do the more challenging part, right? Let's move from COBOL to a Spring Batch in this case. I have reused this picture to illustrate the feeling when we use coding agents in this case, right, for modernization purposes. You have your original application, and you expect to have some kind of good results, right? But you get something completely different. It's the same thing as you delegate something to a developer, right? Depending on the knowledge that they have, so it's going to produce something or another. So the question at the end is how we can help the coding agents to understand the requirements of the application. Because when something is not respected, what is that thingy? So usually that thingy are the inbound and outbound contracts of the existing application. So rewrites, which is the third categorization for modernization, have the following challenges. We want that contracts are preserved, because otherwise you cannot divide and conquer the problem of modernizing multiple applications simultaneously. You need to assume something, because applications services are interconnected. And in order to move them from their current technology to a modern framework in production, you need to do this step incrementally, and you need to make some assumptions. Those assumptions are the contracts that they expose. And for instance, if that application probably is using a database. You cannot simply rewrite the application using a full different schema because the data is there, right? So this kind of requirements needs to be explicitly written so that the application is correctly generated afterwards. And most importantly, usually those legacy apps don't have tests, right? Don't have tests. And because don't have tests, you want that at least the LLM suggests some tests, and you manually, with the running application, validate that those tests are correct and add additional ones. So that the resulting application at least satisfies those tests, right? And this is important because this is the main reason. ThoughtWorks has also reported a similar post. The main reason you cannot promise to migrate from a legacy technology to a new modern technology without putting the human in the middle, right? Because the requirements are vague, and because there are, I would say, different ways of implementing something, you don't know if that way of implementing something was initially correct either. And you want to take advantage of the opportunity to define it properly so that the resulting application is correctly written. And as you can imagine, they are monsters. Those applications are Frankensteins that have thousands of files there, right? And you cannot simply delegate everything to the LLM. But the good news, though, is that you don't want either. You really don't want either. You want to incrementally migrate that functionality into production, because otherwise the risk is so much, and you cannot review thousands of files either, right? So an additional user experience needs to be added on top, because you need to agree on how you divide the application and incrementally move the new code into production. There is a new trend, basically, about using specs as a single source of truth instead of the code, because LLMs are becoming as smart that you can start from specs, right? We are agreeing on this approach, and indeed, we believe that you should use a controlled language for that spec, because otherwise, you cannot define properly how the application needs to be translated. That spec, in the original, I would say, days, could be considered a UML spec, but let's simplify this a little bit. When I'm talking about structured languages, it's a DSL, right? It's going to reduce ambiguity and produce a more predictable Spring code. And as I was trying to introduce, because the time is going down, there is an initial trend to use a spec as the initial source of truth instead of the code per se. And there are some solutions right now available. I have been playing with GitHub Spec Kit. It's really doing a good job, but it's providing an opinionated framework. But none of them are providing an structured spec in terms of a DSL. And the main challenge that these solutions have is the context window. So you cannot simply request them to produce an spec of the existing code base, because it's not going to fit. So our approach has been to divide this problem into these three phases. One is about extracting the user catalog, the user stories catalog. You want the LLM to investigate how you can split the problem into different pieces. And then the smallest unit that you can start is the user story. And all this information needs to be stored in it, so you can reuse it across multiple executions. You don't need to produce it multiple times. And then you generate the spec for a given user story, and that spec, after you are comfortable with the test cases that are produced, and the target and the semantics that have been extracted, you can rewrite them into a Spring. And now it's time for the demo. It's going to be 3 minutes, if you can stay. So this is a COBOL application. It's an open source one. It's very simple in this case. because otherwise nobody's going to understand it. So it's basically a list of records that are, the first number is including the date and amount all together, right? And we want to sort these records first by date and then incrementally by amount, which is the second part, right? This is the input that we are going to use, sorry, and the output. This is the result. And the COBOL app is this file that is basically referencing the inputs and outputs, and it's making this sort. Very long, as you can see, for the operation. And then we are going to start the skill that is going to orchestrate all these three processes. Phase one, which is building the catalog, which in this case is a single user story, but it could be organized by domain and user stories. And then you can see the skill details here. These are the three phases, because while we are waiting for the user story, and here we have the user story with the different acceptance criteria and the technical context, which is where we use the DSL. You see the service batch process. This is describing as well all the inputs and the outputs. And as well, in case that it was an operation that it was using a database, we are going to see all the database instructions as well and the data model that we use. So this was saying that this is a batch operation, and it's defining the data structure is here, the source summary, and the original one. And then finally, it's moving to Spring Boot. And it's requesting me the output where I should store the new application. And what is interesting as well is that as part of this skill, we are using the Spring.io starter, the starter.spring.io, sorry, here, because it's producing the first, I would say, a skeleton of the application, and then we perform the corresponding next steps. And this is the final test that is correlating the acceptance criteria with the answers. And then if we execute the application, we are going to see that it's producing the same outputs afterwards. This is the final result, which corresponds to the same one. Yeah. And this was about some formatting part. Yep. So everything has been generated, the spec, and the initial user story, and the final implementation, because we have only a single user story. And that's basically it. So the conclusions are that upgrades and migrations can usually follow a hybrid model, and you can combine OpenRewrite recipes to reduce the amount of tokens that you need to use and the simplification of the test, and complement that with AI in order to deal with complex use cases, and as well when semantics need to be extracted. And finally, for full rewrites is when you need higher level semantics explicitly defined so that you can define rules to extract and to rewrite those semantics into the target technology. And that's all. Thank you very much.